Hello everyone, this is Kalpana here. In this video, we are going to solve a differential equation using variation of parameters method. So let's get going. Problem: solve y double dash plus y equal to x minus cot x or d square plus 1 into y equal to x minus cot x using variation of parameters method. So we are given a differential equation of order 2. Given differential equation, y double dash plus y equal to x minus cot x. Consider as equation number 1. We can write y double dash as d square y by dx square plus y equal to x minus cot x. And now let's replace d by dx with differential operator d. We'll get d square equals to d square by dx square, right? Let's replace the first term using differential operator. We'll get d square y plus y equal to x minus cot x. Now take y common from the first two terms or the two terms of LHS. We'll get d square plus 1 into y equal to x minus cot x, which is in operator form. Consider the given consider this differential equation as equation number 2, right? Which is in operator form. Say f of d into y equal to some function of x. So equation 1 in operator form is our equation 2, right? Where f of d is d square plus 1 and r of x is x minus cot x. Let's now write the homogeneous equation of equation 2. The homogeneous equation of 2 is d square plus 1 into y equal to 0. Consider it as equation number 3. Now we'll find the solution to the homogeneous equation using the auxiliary equation, and later using the solution of homogeneous equation we'll find the general solution of the given differential equation. Okay. Now coming to the auxiliary equation. The auxiliary equation is f of m equal to 0, where f of m equal to, we have f of d square plus 1, right? Let's replace the differential operator with m, so that we'll get f of m equal to m square plus 1, and the auxiliary equation becomes m square plus 1 equals to 0. Now we need to find roots to this equation. Can write the above equation as m square equals to minus 1, then m equal to plus or minus square root of minus 1, since square root of minus 1 is I, so you'll get plus or minus I. Therefore m equal to plus or minus I are the roots of the given differential, the auxiliary equation, right? The roots are complex conjugate. We got complex conjugate roots. We know that when two roots are complex or otherwise, when m equal to a plus or minus ib, a pair of complex conjugate roots, then the solution to the homogeneous equation looks like y equal to e power ax into one constant into cos bx plus another constant into sin bx, right? In case of a0, we'll get e power 0 into x, which is e power 0. Then we'll get e power 0 into c3 cos bx plus c4 sin bx, right? Since e power 0 is 1, so you'll get 1 into c3 cos bx plus c4 sin bx. This gives us c3 cos bx plus c4 sin bx, right? Now let's write a solution to homogeneous equation. The solution to homogeneous equation 3 is y equal to, now compare plus or minus I with plus or minus IB, then for b equal to 1 we'll get y equal to C3 cos 1x plus C4 sin 1x, right, which gives us y equal to C3 cos x plus C4 sin x. Therefore, y equal to C3 cos x plus C4 sin x is the solution to our homogeneous equation. Here we are taking C3 and C4 instead of C1 and C2 because we want C1 and C2 to appear in the last general solution, right? Now, let's write the general solution of the given problem using the solution of homogeneous equation. Let y equal to, now replace the constants or parameters with some functions of x, a and b, then we'll get y equal to a cos x plus b sin x be the general solution to the given problem, or to 1 and 2 we can see, where a and b are some functions of x, where a and b are functions of x, right? Now we are saying that y equal to a cos x plus b sin x is a solution to the given differential equation, which is nothing but it is a solution, right? We are saying that this is a general solution to our problem, which is nothing but it is a solution to our problem, so it satisfies y equal to a cos x plus b sin x satisfies equation 1, right? So let's find y dash to find y double dash. Okay, we are having y, now we are going to find y dash and y double dash, and later we will substitute y double dash in equation 1. We have y equal to a cos x plus b sin x, right? We are going to find y double dash. So for that we need y dash. Y dash equals to a cos x dash plus b sin x dash. So here we need to find derivative of product of two functions. So we are going to apply uv whole dash formula, which is u dash v plus v dash u. This gives us a dash cos x plus a into cos x dash plus b dash sin x plus b into sin x dash, which gives us a dash cos x plus a into derivative of cos x with respect to x is minus sin x plus b dash sin x plus b into derivative of sin x with respect to x is cos x. This gives us a dash cos x plus into minus minus a sin x plus b dash sin x plus b cos x, right? Now write the terms involving a dash and b dash. Firstly, we'll have a dash cos x plus b dash sin x. Now write the remaining terms, minus a sin x plus b cos x, right? Now let a dash cos x plus b dash sin x equal to 0. Consider as equation number 4, so that a double dash and b double dash will not appear while finding y double dash. Now y dash gives 0 minus a sin x plus b cos x, which gives us minus a sin x plus b cos x. So therefore y dash equals to minus a sin x plus b cos x. So we got y dash. Let's now find y double dash. We have y dash equals to minus a sin x plus b cos x, right? Let's find y double dash. Y double dash equals to minus a sin x dash plus b cos x dash. Here also we need to find the derivative of product of two functions, right? So we'll apply uv dash formula. This gives us minus of a dash sin x plus a into derivative of sin x, that is sin x dash, plus b dash cos x plus b into cos x dash. This gives us minus of a dash sin x plus a into derivative of sin x with respect to x is cos x plus b dash cos x plus b into derivative of cos x with respect to x is minus sin x. This gives us minus of a dash sin x plus a cos x plus b dash cos x plus into minus minus b sin x. We can just write directly by removing brackets. Okay, I'm just going to write one more step. Is equals to minus a dash sin x minus into plus minus a cos x plus b dash cos x minus b sin x. Now write the terms involving a dash and b dash. Firstly, we'll have minus a dash sin x plus b dash cos x. Now write the remaining terms minus a cos x minus b sin x. So we got y double dash. We got y dash and y double dash. Let's substitute y double dash and y in equation 1. We have equation 1, y double dash plus y equal to x minus cot x. Now substitute y double dash in the above equation. This gives us y double dash minus a dash sin x plus b dash cos x minus a cos x minus b sin x plus y a cos x plus b sin x equal to x minus cot x, right? This gives us minus a dash sin x plus b dash cos x minus a cos x minus b sin x plus a cos x plus b sin x equal to x minus cot x. So here minus a cos x and plus a cos x gets cancelled. Likewise minus b sin x plus b sin x gets cancelled, and this results to minus a dash sin x plus b dash cos x equal to x minus cot x. Consider as equation number 5. Now let's solve equation 4 and 5 to find a dash and b dash. We have equation 4 and 5, right, which contains a dash and b dash. Now we are going to solve equation 4 and 5. In order to solve equation 4 and 5, just observe the terms involving a dash in both the equations. We have a dash cos x in equation 4 and minus a dash sin x in equation 5. In order to cancel the terms involving a dash from both the equations, we need a sin x in equation 4 and a cos x here in equation 5, right? We need a cos x in this term otherwise. So we'll multiply sin x to equation 4 and cos x to equation 5. Solving 4 and 5. A dash cos x into sin x. A dash sin x cos x plus b dash sin x into sin x is sin square x, equal to 0. Now multiply equation 5 with cos x, will get minus a dash sin x cos x plus b dash. Cos x into cos x is cos square x equal to x minus cot x into cos x. Right? So here plus a dash sin x cos x minus a dash sin x cos x gets cancelled and we'll get b dash sin square x plus b dash cos square x equals to x minus cot x into cos x. This gives us, I'll just take b dash common from the two terms of LHS, we'll get b dash times sin square x plus cos square x equal to x cos x minus cos x into cot x. Right? Since we know that sin square theta plus cos square theta equal to 1. So we can replace sin square x plus cos square x by 1. We'll get b dash into 1 equal to x cos x minus cos x into cot x, which gives us b dash. That is b dash equals to x cos x minus cos x cot x. So we got b dash. Let's now find a dash by substituting b dash in equation 4. Therefore, b dash equals to x cos x minus cos x cot x. Right? We have equation 4 a dash cos x plus b dash sin x. Right? We can write this as a dash cos x equal to minus b dash sin x, since b dash equals to x cos x minus cos x cot x. So let's replace b dash in the above equation. This gives us a dash cos x equals to minus of x cos x minus cos x cot x into sin x, which is equals to minus x cos x sin x minus into minus plus cos x sin x cot x. Right? Now take this cos x to RHS, we'll get a dash equals to 1 by cos x into minus x cos x sin x plus cos x sin x, or you can take cos x common from these two terms. Okay, it will be easy. Right? Which is equals to minus, just take cos x common from these two terms, we'll get cos x 1 by cos x into, we'll take cos x common from these two terms, so that we'll get cos x into minus x sin x plus sin x cot x. So cos x gets cancelled and we'll get a dash equals to minus x sin x plus sin x cot x. Right? Or we have a dash equals to minus x sin x plus sin x cot x. Right? Since we know that cot theta equal to cos theta by sin theta, so let's replace cot x with cos x by sin x. Then this becomes sin x into cos x by sin x, where sin x gets cancelled, and this results to minus x sin x plus cos x. Therefore, a dash equals to minus x sin x plus cos x. Right? Likewise, in b dash we are having cos x into cot x. Right? We have b dash equals to x cos x minus cos x into cot x. Right? Again, we'll replace this cot x with cos x by sin x. So that we'll get b dash equals to cos x minus cos x into cos x by sin x, which gives us cos x into cos x, cos square x by sin x. Since we know that sin square theta plus cos square theta equal to 1, so we can replace, just take sin square theta to RHS, we'll get cos square theta equal to 1 minus sin square theta. Now replace cos square x with 1 minus sin square x. This gives us x cos x minus of 1 minus sin square x by sin x. This gives us x cos x minus of, in the numerator of the second term we have two terms and in the denominator we have one term. So we can split the total expression into two terms. We'll get 1 by sin x minus sin square x by sin x. Right? This gives us x cos x minus of reciprocal of sin x is cosecant x. Sin square x by sin x is sin x, because one sin x gets cancelled from the numerator and denominator as well. And this gives us x cos x minus cosecant x minus into minus plus sin x. Therefore, b dash equals to x cos x minus cos x cot x or x cos x minus cosecant x plus sin x. Okay, so we got a dash and b dash. Let's find AB. I'll begin with a dash. We have a dash equals to minus x sin x plus cos x, right? A dash is nothing but derivative of a with respect to x. Now, let's separate the variables by taking differential dx to RHS. Then we'll get dA equal to minus x sin x plus cos x into dx. Here the variables are separable, or we can write this as dA equal to minus x sin x dx plus cos x dx, right? Where the variables are separable. Now let's perform integration. Integral dA equal to minus integral x sin x dx plus integral cos x dx. Let's evaluate integral x sin x. So here we are going to apply integration by parts formula. Integral u dv equal to uv minus integral v d, right? Here the integrand is of the form product of polynomial and trigonometric function, right? Let's consider the polynomial function as u and the remaining part as dv. So we have u equal to x and dv equal to sin x dx, right? Here differentiate on both sides with respect to x. We'll get du by dx equals to derivative of x with respect to x is 1. From this we'll get du equal to dx, right? And here we are going to integrate on both sides to find v. This gives us v equal to integral sin x dx is minus cos x. Now apply this formula. Integral u dv equal to uv, that is x into v, minus cos x minus integral v du, which is dx. This gives us minus x cos x minus into minus plus integral cos x dx, which gives us minus x cos x plus integral cos x is sin x, right? Therefore, integral x sin x dx is minus x cos x plus sin x. Since integral x sin x dx equals to minus x cos x plus sin x, the above equation becomes integral dA equal to minus of integral x sin x dx is minus x cos x plus sin x plus integral cos x dx is sin x. This gives us a equal to minus into minus plus x cos x minus into plus minus sin x plus sin x. Here minus sin x plus sin x gets cancelled and we'll get a equal to x cos x, sorry we forgot to write the constant, plus integral constant, say some c1. Okay, therefore a equal to x cos x plus c1. We got a. Let's now find b. We have b dash equal to x cos x minus cos x cot x, right? B dash is nothing but derivative of b with respect to x. Now let's separate the variables by taking the differential dx to RHS. We'll get db equal to x cos x minus cos x cot x into dx, or db equal to x cos x dx minus cos x cot x dx. Here the variables are separable. Let's now perform integration. We'll get integral db equal to integral x cos x dx minus integral cos x cot x dx, right? Let's now evaluate integral x cos x dx and integral cos x cot x dx separately for our convenience. Let's evaluate integral x cos x. Here we are going to apply integration by parts formula. Integral u dv equal to uv minus integral v du. Here the integrand is of the form product of polynomial function and trigonometric function, right? Consider the polynomial function as u and the remaining part as dv. So we have u equal to x and dv equal to cos x dx. So here we are going to differentiate on both sides with respect to x. We'll get du by dx equals to derivative of x with respect to x is 1. This gives us du equal to dx, right? And here we'll integrate on both sides to find v. This gives us v equal to integral cos x dx is sin x, right? Now apply the formula integral u x into dv cos x dx equal to uv, that is x into sin x minus integral v into du, which is dx. This gives us x sin x minus integral sin x dx is minus cos x, which gives us x sin x minus into minus plus cos x. Therefore, integral x cos x dx equal to x sin x plus cos x. Valued cos x cot x. Let's consider the integrand cos x into cot x, right? Since we know that cot theta is cos theta by sin theta. Now just replace cot x with cos x by sin x, right? This gives us cos x into cos x, which is cos square x by sin x. Since we know that sin square theta plus cos square theta equal to 1, this gives us cos square theta equal to 1 minus sin square theta, right? We'll just take this sin square theta to RHS, then we'll get cos square theta equal to 1 minus sin square theta, right? Now just replace this cos square x with 1 minus sin square x. You'll get 1 minus sin square x by sin x. In the numerator you are having two terms and in the denominator you are having one term, so we can split this into two terms, say 1 by sin x minus sin square x by sin x, which gives us reciprocal of sin x is cosecant x minus 1 sin x gets cancelled from the numerator and the denominator, you'll get minus sin x, right? Therefore, cos x into cot x equal to cosecant x minus sin x. Since cos x into cot x equal to cosecant x minus sin x, we'll replace the integrand by cosecant x minus sin x. Now just replace the integrand with cosecant x minus sin x. This gives us integral cosecant x minus integral sin x dx, right? Since we know that integral cosecant theta d theta equal to log mod cosecant theta minus cot theta, and integral sin theta d theta is minus cos theta. So the expression becomes integral cosecant x dx is log mod cosecant x minus cot x minus integral sin x dx is minus cos x, right? This gives us log of cosecant x minus cot x minus into minus plus cos x. Therefore, integral cos x cot x dx equals to log of cosecant x minus cot x plus cos x. Since integral x cos x is x sin x plus cos x and integral cos x cot x is log of cosecant x minus cot x plus cos x, this equation becomes integral dv b equal to integral x cos x dx is x sin x plus cos x minus of integral cos x cot x dx. Just replace the result obtained from the integration, log of cosecant x minus cot x plus cos x, right? This gives us x sin x plus cos x minus log of cosecant x minus cot x plus, sorry, minus into plus, minus cos x. So here plus cos x and minus cos x gets cancelled, and here we need to write integral constant, say some c2. This gives us x sin x minus log of cosecant x minus cot x plus c2. Therefore b equal to x sin x minus log of cosecant x minus cot x plus c2. We got b. And we have a. So let's now write the general solution using y equal to a cos x plus b sin x. Therefore, the general solution is given by y equal to a cos x plus b sin x. Just substitute a and b here. We have a x cos x plus c1 into cos x plus b x sin x minus log of cosecant x minus cot x plus c2 into sin x. This gives us x cos x into cos x is cos square x plus c1 cos x plus x sin x into sin x sin square x minus sin x into log of cosecant x minus cot x plus c2 sin x. This gives us, now write the terms involving c1 and c2. Firstly, we'll have c1 cos x plus c2 sin x. Now write the terms involving sin square x and cos square x. We'll get plus x sin square x plus x cos square x, and the remaining term minus sin x log of cosecant x minus cot x. This gives us c1 cos x plus c2 sin x plus, take x common from these two terms, we'll get x times sin square x plus cos square x minus sin x log of cosecant x minus cot x. Since we know that sin square theta plus cos square theta equal to 1, so we'll just replace sin square x plus cos square x by 1. Then we'll get c1 cos x plus c2 sin x plus x into 1 minus sin x log of cosecant x minus cot x. This gives us c1 cos x plus, see, it's not necessary to write steps, okay, we can just directly write the step by skipping the second one. X minus sin x log of cos x minus cot x. You can just avoid this step, okay, fine. Therefore y equal to c1 cos x plus c2 sin x plus x minus sin x log of cosecant x minus cot x is the required solution to our problem. So we have seen a problem from variation of parameters method in this video. I hope you'll understand. We'll see you in the next video. Until then, bye bye.